Today, we're diving deep into the silent shifts rattling the AI ecosystem, from OpenAI quietly shrinking Codex's context window to Moonshot hitting compute capacity in a mere 48 hours. It's a wake up call for builders. What happens when your core AI infrastructure changes without warning? And how do you build resilient products when the underlying models are in constant flux? No BS AI briefing, brought to you by Proactive AI. Welcome back. I'm your host, Vikash Sharma, and this is where builders get straightforward AI news without the fluff. All right, let's dive into some high signal items that dropped this week. We've got a lot to unpack, especially around the theme of instability and unpredictability in the model landscape. First up, a pretty significant and frankly concerning item from OpenAI. Users are reporting that OpenAI has silently reduced the context window for Codex without any public announcement. Now, this isn't just a minor tweak. We're talking about a reported 27% cut, dropping from 372k tokens down to 272k. Users are noticing more hallucinations and a weaker ability to retain state across longer coding sessions. In plain English, if you've been relying on Codex for those huge multi-file refactors or extended coding tasks where it needs to understand a massive code base, it's likely performing worse. For builders, this is critical. Teams that have built workflows around a large context window might see their tooling break or at least degrade significantly. It means you can't just set it and forget it. You need active monitoring and potentially some urgent redesigns to adapt to these new, tighter limits. It really highlights the hidden dependencies we're all taking on when we integrate these powerful APIs. Next, a story that perfectly illustrates the compute bottleneck we keep talking about. Moonshot paused new Kimi K3 subscriptions after hitting capacity limits. This happened incredibly fast. Within just 48 hours of launch, the demand for their new K3 model maxed out their infrastructure. Now, they've said they'll reopen subscriptions in batches with two tiers, Kimi membership and Kimi Code membership, but the immediate impact is clear. If you were looking to integrate K3 into a product or workflow, you're going to face interruptions, wait lists, and most likely pretty aggressive rate limits once you do get access. This isn't just about Kimi, it's a stark reminder that even well-funded players are struggling to keep up with demand, and scaling truly cutting-edge models is still a massive challenge. So if you're building, you absolutely need to factor in potential capacity constraints and interruptions for any frontier model you're considering. Also this week, Hugging Face published a security analysis highlighting a compelling need for self-hosted models. This came out of some forensics work they were doing where guardrails on commercial APIs actually blocked real exploit payloads. Essentially, when trying to understand how certain vulnerabilities behaved, the commercial models they were using prevented the bad inputs from even reaching the model, making it harder to test and analyze. To get around this, researchers had to use a self-hosted open weight model, GLM 5.2 instead. What does this mean for builders? It's a strong recommendation that you should maintain a vetted, self-hosted open weight model for things like incident response, security analysis, or even just robust testing. Relying solely on commercial APIs, while convenient, can obscure critical insights, especially when you need full transparency and control over model behavior for security sensitive tasks. It's a compelling argument for having that in-house option. Switching gears a bit, Alibaba debuted its Qwen 3.8 Max Preview 2.4T for testing. This is available via their token plan, QORDER, and CoderWork platforms, and Alibaba is positioning it as comparable to other frontier models. Now, what's even more interesting is their plan for an open weight release. For builders, this is great news for diversification. As we just discussed with OpenAI and Kimi, relying on a single provider or a limited set of models carries significant risks. A new powerful non-US open weight option like Qwen 3.8 Max could offer a valuable alternative for those looking to avoid vendor lock-in, manage costs, or simply have more control over their deployment environment. It adds another strong contender to the mix, especially if you're working in regions where non-US models are strategically important. Finally, a fascinating piece of infrastructure news from Anthropic. Claude Code is reportedly running on a Rust-based bun runtime. This was a silent deployment, meaning Anthropic didn't announce it, but it's been active since at least mid-June. Simon Willison's weblog highlighted this shift to a Rust rewrite of bun, which has reportedly led to a 10% startup performance improvement on Linux. Now, this isn't something directly exposed to API users, but it's a crucial behind the scenes engineering move. For builders, it signals two things. First, major AI companies are constantly iterating and optimizing their infrastructure, often without public notice, which impacts the performance and cost of the APIs we consume. Second, it highlights the continued push for performance and efficiency at the platform level, using modern tools like Rust and Bun to squeeze out every bit of speed. It means the back end of these services is never static, and those subtle optimizations contribute to the overall reliability and cost effectiveness of what we build on top of. Now, out of all those stories, the one that really demands our attention today is OpenAI's unannounced reduction of Codex's context window. This isn't just a technical detail, it's a symptom of a larger, more critical issue facing all of us building with AI. What happened? Well, users, mostly developers and engineers using OpenAI's Codex, their coding specific model, started noticing something was off. Their prompts that used to work, especially those needing a lot of code context, were suddenly failing or producing much worse results. After some digging and testing, the community on Hacker News pinpointed it. Codex's context window, which was a robust 372,000 tokens, appears to have been silently cut down to 272,000 tokens. That's a 27% reduction without a single word from OpenAI. This isn't speculation. People are seeing real world impact in their production systems. Why does this matter right now? This matters because it's a fundamental change to a core capability of a widely used model, and it happened with zero transparency. Imagine your cloud provider suddenly shrinking your allocated memory or CPU without telling you. It breaks things. For Codex, that massive context window was a key differentiator, enabling developers to feed in entire file directories or large code bases for analysis, refactoring, or bug fixing. Now, workflows built on that assumption are crumbling. It erodes trust, yes, but more importantly, it introduces significant operational risk. How can you plan roadmaps, commit to features, or even guarantee uptime if the underlying models you depend on can change their fundamental capabilities overnight without a warning or an apology? So, who should really care about this? Founders need to care because it directly impacts your product's reliability and your development team's productivity. You're building a business on top of these APIs. silent breaking changes can hit your bottom line. Product managers, you need to be asking how these shifts affect your product's performance metrics and user experience. If your AI powered feature relies on a large context, its quality might have just taken a dive. And forget infrastructure engineers and indie hackers alike. This is a clarion call for architectural resilience. You need to think about fallbacks, model diversification, and active monitoring to detect these unannounced changes before your users do. It's about risk management at a fundamental level. How would I think about this as a builder? This is a stark reminder that even with frontier models, you're always operating on rented land. You don't control the infrastructure, the scaling priorities, or the internal economics of these large providers. My mental model here is the API contract. When you integrate an API, you expect a certain contract, input, output, and performance guarantees. A silent context reduction is a breach of that implicit contract. As a builder, this pushes me towards a multi-model strategy where possible. Can I abstract away the underlying model enough that I can swap it out if one provider makes a change? Can I implement guardrails or retry mechanisms that can handle reduced capabilities? And crucially, it highlights the value of having a strong open weight alternative or even an in-house fine-tuned model for mission critical tasks where you absolutely need stability and control. Don't put all your eggs in one provider's basket, especially when they're proven to shift things without notice. My no BS take on this isn't hype, it's a cold hard dose of reality. The era of unchecked, ever increasing capabilities from a single AI provider is probably behind us. We're entering a phase where compute constraints, internal optimizations, and market dynamics will lead to more unannounced changes, sometimes even downgrades. Builders need to adapt by prioritizing robustness, observability, and diversification in their AI stacks. Trust, once broken, is hard to regain. If you want one practical takeaway from today's episode, especially in light of the OpenAI Codex news and the broader theme of unexpected changes, here it is. Audit your existing Codex usage for context risk. Bold show. This isn't just for Codex users, but as a mental exercise for any critical AI API you rely on. Here's how to try it in under 60 minutes. Ponder 1. Identify your most context sensitive workflows. Take 15 to 20 minutes to list out every feature, internal tool, or development process in your team that uses Codex or any other LLM where a large context window is crucial. Think about tasks like cross-file refactoring, summarizing long documents, or complex code generation that needs an entire code base. 2. Estimate current context usage. For each identified workflow, try to get a rough idea of how many tokens you're currently sending to the model. You might have logs, or you can run a quick test with typical inputs. 3. Simulate a reduced context. Now, mentally, or actually, if you have the time, consider what would happen if that model's effective context suddenly dropped to 272k tokens or even 200k. Which of your workflows would break entirely, which would degrade in quality? 4. But prioritize potential fixes or fallbacks. For the workflows identified as high risk, brainstorm initial ideas. Could you implement chunking strategies? Add a summarization step before sending to the LLM? Or would this be a strong candidate for an open weight model fallback you host yourself? Why is this specific experiment worth your time right now? Because the cost of being caught off guard by a silent downgrade or even a capacity issue like we saw with Kimi K3 can be immense. It's about proactive risk management. By auditing your context usage and thinking about these scenarios before they impact your users or your team's productivity, you're building resilience into your product and your engineering practices. It shifts you from a reactive posture to a proactive one, which is essential in this fast moving, sometimes volatile AI landscape. That's it for today's No BS AI briefing. If this helped, follow the show in your podcast app and share it with one builder you know. And if you've got questions or topics you want covered, connect with me on LinkedIn and send them over. See you in the next briefing.